Alright, we are going to go over and practice some of our balancing of chemical equations. It's hard to see in the Zoom and hard to understand without actually watching me go through a couple of problems. So I'm going to do a couple for you from your equation sheet. Remember, today you need to have 15 of the 20 done. So there are 15 problems, or there are 20 problems, 15 of those are due today. You should have already done some yesterday, so this shouldn't take you too long. So if we looked at, say, number 9 on balancing equations, practice number 1, our equation says we have carbon dioxide plus carbon is going to yield or create blank number of carbon monoxide. So the very first thing that we do is to separate the reactants versus the products. We know that the reactants are anything on the left-hand side of the equation. So these are my reactants, and this is my product. The second step in our solving or balancing chemical equations is to write down what you have. So on my reactant side, I have carbons and oxygens. I get one carbon, and this is important. You might be able to do this in your head, but as our chemical equations get more complicated, this is going to become harder and harder for you to do in your head. So you need to be writing this part out in pink. So we have 2 carbons total on the reactant side, so I put 2 right here. I have 2 oxygens total because of that subscript right there on the reactant side. And on the product side, I have 1 carbon right here, and I have 1 oxygen. Remember, when I have something like CO or carbon monoxide, there's an understood 1 subscript there. If I have something, and that molecule would look something like this. If I have something like carbon dioxide, that means I have carbon bonded to 2 oxygens. Carbon dioxide, and we denote that there are 2 oxygens by the little subscript 2 right here. So my question to you, is my chemical equation balanced? The answer is no, because we don't have the same number of carbons on each side. We have 2 carbons on the reactant side and 1 on the product side, and we don't have the same number of oxygens. We have 2 on the oxygen side or on the reactant side and 1 on the product side. That means we need to add a subscript here, or move on to step number 3, which is to add a subscript, or not a subscript, a coefficient, excuse me, a coefficient to balance these out. So your options are the blanks here. I could put one here, here, or here. Because we see the lower side being on the product side, we're most likely going to put a coefficient on the product side. So that means right here. So my question to you is, what number would I need to put here in the blank so that I have 2 carbons and 2 oxygens? Hopefully you were able to answer in your head that if I simply put a 2 right here, that would change the number of carbons I have on the product side and the number of oxygens I had. So before, in pink, I had just 1 carbon bonded to 1 oxygen. Because I put a coefficient here, that means that I have 2 molecules of carbon monoxide. So I have an additional molecule in green. That means I have 2 total carbons, so that changes that number. And I have 2 total oxygens, so that changes that number. Now, my question for you is, do my number of carbons match my number of carbons on my products? The answer is yes, we have 2 on each. Do my number of oxygens on my reactant side match my number of oxygens on my product side? The answer is yes, I've got 2. So now, with the coefficient of 2 there, this is balanced. You do not need to put, you could, if you wanted, put a 1 right here and a 1 right here, but you don't need that, because we know that if there's no coefficient in front of my molecule or compound, that is an understood 1 right there. So if I just had carbon dioxide, it would be the same as if I have 1 carbon dioxide, because it's an understood 1. We're going to do another one together. go to balancing equations practice sheet number 2. Let's do we'll do one with our parentheses. We're going to do number 8 on balancing equations practice number 2, which tells us that we have Zn, or zinc, SO4 plus unknown coefficient K, 3PO4, yields or creates Zn3, parenthesis PO4 squared, plus blank unknown K2SO4. This one's a long one, that's why we're doing it. So we know whenever we have a parenthesis, we're multiplying the number in here twice to each of whatever's in my parenthesis. Before we do that though, we know our reactants are on the left side of the arrow, so these are my reactants, and these are my products. Now we need to do step number 2, which is to count the number of each type of element in the reactant side and the product side. So we know we have zinc here. I've only got 1 zinc. We've got sulfur, potassium, and oxygen. I've got 1 sulfur. I've got 3 potassiums, or Ks. And I also have phosphorus. I missed that one. I have 1 phosphorus. And I have 8 total oxygen. So this one is a doozy. Then if I go over here to my product side, Zn, I have 3 zincs right here. I have not 1 phosphorus, but 2 because of the parenthesis. I've got 4 oxygen from not 4, I've got 8 oxygen right there, plus 4 from over here, means that we have a total of 12 oxygens. My potassium, or K, I have 2, and my sulfur, I have just 1 again. Okay. So we're going to go through now and try to balance this out. The first thing that I see you're going to want to try to balance from a lower side is that zinc has 3. This is definitely not balanced. Zinc has 3 on the product side and 1 on the reactant side. So the very first thing I'm going to do is try to balance that zinc out. So that means I'm going to need to go to the reactant with the zinc, which is right here. If I put numbers right here, it's not going to change my zinc. So what number would I put as a coefficient right here to try and help balance this out? I would put a 3, but that would change all my numbers. So I'm balancing my zinc out. Now I have 3 zincs. But now I've changed my sulfurs because we take the coefficient times the subscript, which is an understood 1 because there's nothing next to that. So 3 times 1 is 3. So now I have 3 sulfurs. And I've also changed my number of oxygen, which is good because I wanted to change them anyways. So 3 times 4 is 12 oxygen, plus my 4 already is 16 oxygen. And I didn't change my potassium because it's still 3. And I didn't change my phosphorus either. So now my zincs are balanced. Check. We're going to put a little check, and we're going to try not to touch our zincs anymore. But now my sulfur is unbalanced. My phosphorus is still unbalanced. My oxygen is still unbalanced. And my potassium is still unbalanced. So we're going to go and now try and balance out. Let's try the sulfur. So we have 3 sulfur over here. We want 3 over here. So if we're trying to change the sulfur, we're not going to change this, especially because my zinc is perfect now. I don't want to change that. So we're going to go over here to this sulfur, and we're going to change that. So we want this sulfur to be 3. So this is an understood 1. That would mean we need a 3 right here to try and balance that out. So if I put a 3 right here, that changes my sulfur to what I want it to be, which is 3. But it also changes my potassium, my K, and my oxygen again. So my K now is not just 2 anymore. It is 1, 2, but I have 3 molecules of this, so I have 6 now. The way I figure that out mathematically is I multiply 3 times 2, which is 6. So now I have 6 potassiums. But it also changes my oxygen, so now I need to multiply 3 times 4, which is 12. But then I need to add in the original 8, so 3 times 4 plus 8 equals 12 plus 8, which equals 20. So now I have 20 oxygen. So now we've balanced. Let's see, our sulfur is good. Our potassium is not balanced anymore because we've got 6 now. And our phosphorus is not balanced, so I can put a check near my sulfur. But my potassium, which is K, my phosphorus, and my oxygen are not balanced anymore. So I've done that. I want to leave this the same because my zinc is balanced, so now I need to go back to the reactant side and change this coefficient so that I have 2 phosphorus and 6 potassium, and I need my total oxygen to equal 20. So I would do that by putting a coefficient of 2 right there, because that would change my potassium. If I'm looking solely at my phosphorus, my P, the 2 times the understood 1 is 2. So I've changed my phosphorus to a 2 now. But I want to figure out how many potassiums I have now. 2 times 3 is 6. So now my potassiums are balanced. My phosphorus is balanced. The only thing left is my oxygen. Let's see if this works out. If it doesn't work out, you have to start all over. So my oxygen is 2 times 4, which equals 8, plus my 3 times 4 from my first compound, which equals 20. So my oxygen is now 20, and that checks out. So now my equation is completely balanced. So those were just 2 examples. Yes, they take a while. Yes, they are frustrating, but once you get this and the more you practice, the better it's going to be. For your assignment, if you give me assignments without the pink and the green in it, I will not grade it. So if you were to give me just what is highlighted right here, so even if you had the correct coefficients and you just gave me the coefficients, I would not accept that as an answer because you can simply Google the answers to these questions. I need to know that you know how to balance. The only way I'm going to know that is if you show your work, what's in pink and green right here. So that's just 2 examples. Again, you need to have 15 total. 15 total. Done. If you're an online student, it's going to be helpful for you to write them out like this. This is how I would prefer to do it. If you put your answers simply on the slides that I gave you, you won't have full credit either because you didn't show your work. So show your work on a piece of paper and you can turn it in. 15 total out of 20. All right, that's it, guys. This was some great practice. Keep practicing, keep trying. You'll do just fine. Have a great day.